Hey everyone, in today's video, we're going to see about machine learning pipeline architecture. I'm going to show the entire flow, what we need to do step by step, and at last, how we can manage this entire pipeline. So, the first step is collecting data. Data collection should happen continuously because just have like versions of data like data set 1, data set 2. Because when we feed the new set of data, the model may get confused, or even if you are coming back and taking care of the model in between, if it is misbehaving, you need a clarity on which data set it is performing. So you can combine both, or you can just direct with a new data set. So for that, you need to name it properly. So collecting data set is constant way of doing, which is continuous data collection. And cleansing and splitting, always maintain a default code so that it can handle the new set of data as well. So cleanse and split should have a default code, and understand some of packages may vary year by year, and they'll get update in the package or function calls and all. So understand that and try to manage it properly by giving proper comments for your code. And next is custom training. So training comes under your model. So when you do training with a particular algorithm, in future you may add some other algorithm or replace with another model. For that, try to write a code accordingly. And model versioning, same thing. If it is updated version comes in, it should handle. So you need a separate model registry for that. So using Vertex AI can help you that. And also, we are doing this in GCP. So any cloud platform which will support these kind of tasks. And serving endpoints. So endpoint is something that it is under delivering such thing. So when we are providing the final results, it is not going to stop there. So it is the problem is after that. So it should perform well, like it may happen better in your system and not performing well in the live data. So there is no such case will happen when we have this proper setup. And CI CD, I mean the continuous development and integration pipeline. So whenever there is a new thing comes in, everything should be automated and served properly. So this is the approach, I mean the idea for ML ops, and we'll just see how it is like structured in code. So here data integration is a collecting part where I'm just going to save it as a blob inside a bucket, Google bucket. So here I can just directly give a file name inside a bucket which I created under my model folder. So directly I'm feeding the bucket name. So every data set that I just named as each version. So spam data set 1, 2. So the data which is from this folder, and raw data after cleaning. So anything it may be, just name it properly and make it work. And processing. So here is another one. Everything what you see is a constant code. You can't just come and change every time. It's supposed to work properly for n number of times and continuous way. So it is not for changing it. But okay, I am getting an error. I'm going back and changing. No, you should not get error. That is why this entire idea is about. Okay, so pre-processing, a default pre-processing, or you can feed your set of pre-processing code and include it. Have a feature engineering model and a proper feature engineering, so that you handle every column and rows better, so that your model training can happen peacefully. And AI platform. So Google Cloud. So whatever we do and see in here, It is all with different packages. It depends. Here I'm using KFP and the artifacts, I mean the default data sets in order to handle it for spam and ham. You can use for depends on your set of data, and model training I'm doing with a certain packages which offered by which can handle by Google Cloud, and evaluation. So metric is very important when it is under MLOps, because it is going to decide whether it is a win or lose. So if it is performing well and stops in between, you can't just go back and check each and every step. It should tell you that where it is actually a problem. So include that step also in evaluation metrics. So this is like not just accuracy, and also a logs that I'm recording, like where it is actually having any issues. If it is not, let's see like how long it is going. And next is deployment part. Here in general, we used to do it as a pickle file or a folder sharing. So, but here we just give a model name, a same bucket we can have in order to call and use it. But when it comes to live, it will be on a demand basis. And whether it's a data, it just do this entire thing and have it is stored as a model name, and we can have it. So at last, we need to monitor it. In general, we validate the entire model. In local, we train and do it. That is a traditional way of doing. But when it comes to ML ops, we should have a proper monitoring techniques. So that also Google, I mean GCP offers model monitoring. It's a package name that you can call directly. So you give a project, I mean the location, endpoint ID, and give the data set. So all the path and I specifically mention each and every step into it so that you can handle it. Uh, so in general, how it should look at last in the sense like when you feed any data, this is how this validation supposed to happen. So that's how you can validate the model from your end, and later you can do any changes in between. But frankly, I would say that try each and every step in local using Docker, and then go with the Google platform. Don't just directly go and do it from scratch there. So here we just check, and we can use LLM for it in order to compare like why it is happening based on the log file that we save, right? That based on that we can understand and summarize what is happening. So the yes, this is also included, and you can just plug in with those features which is available to see the latency of it and accuracy and the score. I mean, the health wise, like how it is actually working or performing. So that is how you can manage this entire architecture. It may sound simple here because I just compressed everything and summarized those steps, but it involves with a lot of work when it comes to different use cases and data set. Spam and ham is one you know a fancy data which is open source, and it is very clean and fine data, and there is no much of pre-processing required. So if you are using any raw data, junk data, you can uh, you know can experience few things while deploying it. So that's all I have for today. Let me know in comments if you want uh, something more about this. I'm ready to do that. So thank you guys. Bye.